So actually, to give you an idea how the experiment is run, I have created a simulation of the experiment on an Excel file. I mean, it's a very crude effort. I mean, it can be improved a lot. I mean, I just made an Excel file to show you how the things would work. Okay, so okay. So basically, there are so what I have done here, as if the instead of the experiment, I have done some calculations within the Excel file, but the inputs will be exactly similar to what you give in the experiment, and this is how you will get the results. Okay, so suppose so so first, so whatever is this gray cells are the ones where you should put the input. Other values are internal data or given data. Okay, so here I have to, because I am using an asbestos powder, I know, so I have put a value of thermal conductivity 0.15, but I will do the calculation and see whether I am getting those values. Okay, so first you need the ambient temperature. So I'm putting this as 30. Okay, then these are the thermostat readings, that means the heater control unit readings. So these values are not actually used in calculations, but you choose the thermostat input values in multiples of zero point 0.5 by trial and error, such that the voltage readings are approximately 40 volt. Okay, so suppose I give it as 2. Then you see that the voltage input is 27.9, so it is less. So I increase it. I make it 5. It is it is a little higher, but so maybe I can make it a little less. So, so basically, this is how you will. So what I am doing here. So basically, this is what you will be doing with this knob. This is basically what you will be doing with this knob. Just by rotating the knob, you will be doing it. So if I take the value as so you get first you get a value of 50.3. I mean, this I am taking. I mean, I have some readings where you will see that the values are like this, and this age also I do not know. I mean, this can be sophisticated, more sophisticated. I just take an approximate value of what should be here the free convection. So if we take a value like this, so we get. Uh, Here the values like this. So you get 50.3 and 0.129. These are the uh, current input you get, voltage and current input, and corresponding. So this will be the 4 inner thermocouple readings and 6 outer thermocouple readings. So here, what has been done to simulate the actual experiment, some random error has been added to it. Okay, so that's why they are not exactly the same value. Okay, So here basically with the help with for this kind of heater power input, this should be the range, this should be the range of temperature. So this is we are getting the first set. So similarly if we do put another second set, so maybe I put 8, I get some values. So maybe I want to increase it further. So the first one was close to 50. So the second one, if I want to make it close to say 60, so maybe something like this. So now I get something close to 60. So by trial and error, you can get it. Similarly, for the third one, I want to get it close to 70. So let me see whether if I put 11, it is not so. If I, sorry, if I put 12, then it is close but not quite. So I put it as 12.5. Then I get very close to 70. And the next one I will take close to 80. Let me put 15. No, I have to increase it a little bit more. 16, it is close to it. So if I just put so you get values close to 50, 60, 70, and 80 volts in the voltmeter, and you get the corresponding values. These four are the inertial temperatures, these higher values, and these six are the outer shell temperatures. Okay.
Yes, sir.
I mean, this is how we will get it. So now if we want to do the post processing, the post processing part is done exactly using the formula that I showed you, and which you have to do by hand. So if you just put the value y, then you will get the values. So here, because of some error that has been introduced, you are not getting the exactly the same value, point 0.1. I mean, actually, it should not be so. I mean, when I am doing, I can this simulator can be improved by say at different cases. For these different power levels, the heater inertial temperature is there is significant difference in the inertial temperature. So what should be the the thermal conductivity at those levels of temperature that I should calculate and do it. So it can be, if we know the temperature variation, I mean variation of thermal conductivity of asbestos with temperature, how it varies, say in a table kind of thing, then we can prepare a table where this heater input and the corresponding thermal conductivity values will also be changed. And actually I have done this over the last couple of weeks after this latest spate of lockdown, when I found that you cannot go and do the experiment in the lab. So I just tried to give you a feel of how the readings are taken and how the readings are generated. So that's why I did this. So this can actually be improved a lot. I mean, in the sense that you can take the measurements, and uh, there are a lot of data available in the lab from the previous years. So using those data, you can fine tune these values like this heat transfer coefficient and things like that. But the process is more or less the same. Okay. So this is what you will be doing.
Sir, one thing just from curiosity, sir,
Yes.
in the means as you are doing in the Excel, if you are putting the same formulas, there should not be any errors. So means how are you generating the random errors?
Oh, random error. What I am doing is that when I am putting these temperatures, okay, I'll just show you what I have done. No, not yet. This one. So basically here I have
So
put
could you
the,
repeat? Actually, your audio was breaking.
okay. So what I have done here is that I have put the formula, I mean the calculation that I have done, I have taken a heat flux input, I mean heat flux input as the boundary condition at the inner location, and a convective heat transfer and a convective heat loss at the at the outer surface, so that that gives me, so that my temperatures come out as function as part of the solution. I do not have to provide the temperatures as input because my inputs are the heaters are the heater powers. So that is how I am doing the calculations here, and after the calculation I am
Yeah, I
adding
can see
some,
the
I am
value.
adding some random number. Actually, I
Okay.
could have changed it a little bit by making it using the function rand between. I mean, here the error is always a positive error. I could have made it say something like varying between point 0.1 I mean point 0.5 and minus point 0.5. So this kind of thing. I just put a random error. I mean, nothing
Yes, yes, I can understand.
nothing more sophisticated. I mean, there are ways in which you can make much more sophisticated things, like whatever the error in your measurement devices and those kind of things. But I mean, it can be improved a lot. But this is just to give you a quick idea. So, in fact, if any one of you can want to work on this and improve on it, that would also be great. I mean, for example, if some of you who are good in good in making simulations. Is a very attractive version of it would be, instead of just keying in the numbers, say you have a visual interface where apparently you just change the dial like you would do in the actual experiment.
Yes,
So
that will be means.
So if you put your pointer to the mark of say 6 volt, and and lock it, say something like that, then you would get the value. So this kind of things, what you would actually do in the experiment. So these kind of things can be done. I mean, people have been doing it ever since this lockdown thing has come up to simulate.
There's a website. I don't know whether it does this kind of experiments. I mean, it did some electrical experiments. Amrita Labs.
Okay.
Uh, তো মানে তো
Ma'am,
ওখানে এরকম
because
অনেক কিছু হচ্ছে আর কি। এবার সেটাই এগুলো হয় কিনা জানি না। মানে ওটা জাস্ট একটু মানে ওটা গ্লিচ ছিল অনেক, মানে হ্যান্ডেল করতে একটু দেরি হতো বা করতো, কিন্তু ওখানে আপনার এরকম আর কি, ওরকম ওরা ভার্চুয়াল জিনিসপত্র দিয়ে দেয়, নব টপ ঘুরি করা টরা যায়, এরকম টাইপের একটা
হ্যাঁ,
ব্যাপার।
হ্যাঁ, হ্যাঁ। তোমার মানে এনপিটিএলও কিছু এরকম আছে যেগুলো তোমার এ, মানে ওই, কিন্তু সেগুলো আমি দেখেছি যেগুলো মোস্টলি ভাইব্রেশন বা এই ধরনের এক্সপেরিমেন্ট, মানে কিছু মেকানিক্যাল ল্যাব, মানে ওই মানে কি যেন ভার্চুয়াল ল্যাব না ডিজিটাল ল্যাব কি একটা বলে ওরা,
yes, sir,
একটা
okay.
ভার্চুয়াল ল্যাব আছে ওদের।
ভার্চুয়াল ল্যাব। তো তো এটা তোমার ধরো মানে সারা পৃথিবীতেই বহু লোক এরকম করছে, মানে আমি দেখেছিলাম। সো লেট মি স্টপ দ্য রেকর্ডিং। So mm, so do you think this will be? I mean, this is interesting. I mean, this simulator kind of thing.